pleasure to meet you. If you are seeing this for the first time, my name is David Awad. I am a developer evangelist here at R3 working on Corda. Joined with me in the chat is my colleague. His name is Peter Lee. We are both developer evangelists here at R3 working on Corda. So with all that being said, today we're going to talk to you about trade finance with letters of credit and Corda. It should be pretty interesting. And if you have any questions, feel free to share them in the chat, or if I'm not able to see them, Peter definitely will. So we'll be able to catch them. So why not? We'll just jump right into it. So the typical resources are always available. You can find us on YouTube. You can find our free training site on training.corda.net. Our Slack is public on slack.corda.net. The documentation, as always, Corda is open source. You can email us, and you can find us on Twitter with the hashtags Corda and R3. So the goals today, in any event, is to talk a little bit about Corda and trade finance. We'll do a brief introduction to the Corda abstractions themselves. Then we'll talk a little bit about bills of lading, letters of credit, and how trade finance seems to actually work. Then we'll do a demo of what a production application of this might look like in Corda on the blockchain. And then we'll talk about how you might implement it as far as Corda apps are concerned. So let's get right to it. R3 as a company has been thinking about trade finance quite a bit this quarter. So some of the big themes you might see where blockchain can be really useful is things like payments and settlements that are on ledger, know your customer and know your supplier laws, things like negotiable title documents, things, the other examples that we like to talk about. We've been running experiments with some groups like TradeShift, GT Nexus, Bank Trade, and Temenos. We've also had some conversations with groups like Infosys, Finastra, and Intellect, who are thinking about building new products on top of Corda, which is a big deal. So there are things like invoice management solutions already out there in the wild, as well as the database and banking providers like Oracle and Silver Lake. Some other cool use cases we've seen are things like custody transfer, contract management, and commodities management. So those tend to be really interesting use cases. So what exactly is an electronic bill of lading? We titled this CorDapp, or rather the CorDapp, when it was originally built a while back, was called the Letters of Credit CorDapp. The idea was that it was meant to broker trades between international exporters and importers of products. So the scenario here is exactly that. It's an electronic bill of lading. So trade finance is sort of well understood, but let's define some intuitive requirements just to get us all on the same page. In trade finance, we want the ability to monitor digital assets. We want to accept and manage derivative assets, such as debt instruments, like a letter of credit. You also want the ability for sellers to communicate with banks to receive those letters of credit. You want, of course, a rock-solid infrastructure underneath all this to make sure everything works. So letters of credit are a fun example because it is, in many ways, just a contract. It's a derivative that's exchanged between two parties. Usually it's created by a bank on behalf of an individual or a company, something like that. So it wasn't always the case that it was possible for things to be done electronically. So I have a fun trivia question for you. I'm curious to see, if you were a lawyer in the 13th century, how might you create a contract such that you could know that it wasn't going to be forged? What might be something you would do to prevent fraud? I'll tell you the answer to this. I actually know lawyers in the 13th century had a very interesting trick for ensuring that they knew exactly what their contracts were and that they would not be modified against their expectations later on. So feel free to throw in the chat if you've got an idea. If you're a lawyer in the 13th century, how would you know, or what might you do to prevent fraud on your contracts? Give it a couple seconds here, see if anyone's got an idea. Well, I'll take that as we're all stumped, and it actually is kind of a hard question. Imagining you're an attorney in the in that time period, it's not exactly obvious how you could prevent anyone from tricking you as far as their contracts are concerned. So the actual secret is that lawyers used to use sheepskin as the parchment for their contracts. Sheepskin, the way that fat kind of marinates within the layers of skin, makes it very clear when people try to modify the contracts after the fact. And so you could not easily modify the text of your contracts after the fact. So you would write your contracts, you would issue them to someone else, you would both sign them, and then you would store them somewhere safe. But then you would never be able to actually go and rub anything out or modify them after the fact. So if you're curious about how that used to happen, feel free to take a look at that link I just threw in the chat. It's pretty fascinating stuff. In any event, we don't need to use sheepskin as we live in the modern day with computers and all of those wonderful tools. So let's actually talk about what you might do, or what does the software stack for a letter of credit or a modern trade finance solution, I should say. What does that look like? A notable example is actually Bolero, who is doing something pretty similar to this, using Corda, that is. So we're going to deploy Corda nodes for our notary, our issuing bank, and our advising bank. These are the banks on both sides of the trade, as well as the importers and exporters. We're going to have a web server that we run, as well as a site for customers and bank employees to access, is the idea anyway. A website and web server for people on both sides of the trade to access, to observe the state of the world, knowing that on the blockchain it is immutable and unfakeable, unhackable, if you will. So what I want you to be aware of as far as this, actually, I should say, before we jump into specifics of how we're going to implement the bill of lading and the letters of credit for international trade, I'm just going to walk you through the components of a smart contract really quickly. We've got three critical ideas that I want you to take away from this workshop with. Those are called states, contracts, and flows. They're relatively intuitive, and we can speed through them here if for the sake of time. But if you have any questions, please do feel free to throw them in the chat. So we're going to talk about states, contracts, and flows. States are the objects themselves. My favorite example is, for example, a car. If I want to create a new car, I have to issue it out into the world as a manufacturer. But the car is the object. So the car has, let's say, a name. Maybe it has a VIN number. It has a, I don't know, it has a tire pressure per tire. It has all kinds of data you could track about this. Number of piston rings, the OBD specification, whether it's OBD1 or OBD2, all kinds of stuff like that. So you could have all kinds of things tracked within a data structure that's just complex enough to encapsulate at the level of detail you want your car. That's not news to anyone. So that's really all that a state is. It's an object you can represent digitally, in this case, through the JVM. Any JVM compatible language will let you represent an object digitally. Those objects are called states. So they only exist in the participating nodes of the specific transactions. This is an important note that I want to make. As far as the actual way that this code looks, every state is going to exist as a JVM class, and the only Corda nodes that will see them are the Corda nodes that are a part of those transactions. So your state, just to finish this off, we can define things like integers for amounts. Now parties, as far as this class is concerned, this is a Corda specific abstraction. So keep that in mind, that parties are generally one party per node. Now, if you're using the accounts SDK, this is slightly different, but the idea remains the same for our case that we're talking about here. Generally, one individual or one company is going to run a Corda node, and they will use that to transact with other Corda nodes representing other entities. So what happens when they do interact with those other entities? The nice thing is that most of these transactions are completely private. They are point to point. So for example, Carl and Ed can have a lot of different transactions between them. In fact, 9 and 4 can be shared between Carl. And if 3 is shared between Ed, Carl, and Demi, Demi cannot see 9 or 4. Demi can only see transactions Demi has been a part of. Similarly, Alice and Bob have this one transaction, and no one else on the network can see that one. It's only for Alice and Bob. And again, that token state is only going to be specific to them and what they are doing. So for example, it's not necessarily the case that 1 is the same kind of Corda state as 5 or 6. It's only, this diagram is only modeling how the states are actually stored in something called the vault on each Corda node. This might be sounding a little bit confusing, but let's abstract out a little bit and imagine the idea that I've defined a state, in this case, token state as our simple example, a token representing someone who issues it, someone who owns it, and an amount. So if Alice issues a token to Bob, that is one state shared between the two parties. But Demi and Carl could be running a completely different CorDapp on their two Corda nodes and run a transaction between the two of them. The interoperability is baked into the fact that when we compile our CorDapps, they're just jar files that we copy onto the particular nodes that we want to run those CorDapps. But that's a little more detail than we need to worry about. For now, just keep in mind that states are objects, and the only people who are aware of them are the people who need to be, and no more. So, Corda contracts and a CorDapp. We talked a little bit about contracts earlier. Contracts define what can you do with the particular objects that you have. So if I have an object like a car, how might I define a contract for it? Well, for a car, you'd want to issue a car. You also might want to sell or transfer ownership of a car, right? And so in Corda, we use the unspent transaction output model, which means that generally we'll have input states that are consumed. Those input states are consumed by transactions. And those transactions, if they consume an input, will produce a desired output. If they do not consume an input state, then they only produce an output. Those are called issuance transactions. So generally in any transaction, all we do is define a series of rules that have to be true, right? So in this case, let's say the contract rules for transferring a car, right? We define something called a command that transferring the verb, if you will, the verb of transferring the ownership of that car is called a contract command. And so a contract itself supports multiple commands. The contract defines all of the commands that you can use on a particular object. And so if I'm transferring a car from me to you, you are purchasing the car from me. I have a series of things that must be true about this car in order for it to be valid, in order for me to give it to you. There is the basic meta level stuff about the contract transaction itself, which is that if I'm transferring a car to you, the car has to already exist on the blockchain. I have to legitimately own the car. If I'm going to give you a car, then you have to purchase the car from me. The car has to exist, be on the blockchain. It can only be one car. There can only be one output transaction. I'm giving you only one car. It's not possible for me to take one car and give two people cars. I can't double spend. My desired output state is going to be a car with you as the owner. Both of us have to agree to this transaction. And in New Jersey, for example, if I'm going to sell you a car, the VIN number has to correspond to the actual car itself. The VIN number also has to correspond to the manufacturer. The driver's license must be 6 characters. The car must have a non-zero positive mileage. That's another one. And so you can start to see how we can start to build a lot of really nice intuitive validations onto all of our normal transactions and remove a lot of those kind of human errors. But those things do happen. And so if we have a transaction that is initiated that is not actually valid for any reason, the transaction fails and it is rejected. The ledger update simply never happens. So if that makes sense to you, then flows are going to be very easy because all we're doing with flows, whoops, sorry, that is an issuance transaction. Flows are going to be very easy when we see that token contracts are just a matter of if statements, functionally speaking. It's just a matter of checks. Flows in a CorDapp are going to be as simple as saying a flow is the process of triggering a contract update. And so, for example, node A is a contract that node A represents the Corda node of a person who wants to initiate a contract update. So let's imagine Alice is selling Bob a car, where node A is the Corda node running on a machine that represents Alice's Corda node. Node B is a Corda node running on a machine that represents Bob's future interest in the car. So what does Alice do? Alice goes to her Corda node. She triggers a flow to propose an update. transferring ownership of the car from Alice to Bob. So Alice's Corda node will propose this update on the blockchain. It will check it by running the contract verifications that I described. Remember, that's checking the number of characters in the license plate. That is ensuring that the VIN number corresponds to the manufacturer. Those kinds of things, very nuanced, very specific, very concrete, very deterministic contract verifications, essentially if statements. And we're going to run through all of them. And once we have signed the update, we've said this is a valid update, I want to publish it to the blockchain, we have to outline and get verification and acceptance from all of the required signers. And in this case, there's really only one. That's node B. I'm giving the car to Bob. I'm not giving it to Charlie or Demi or Ed or any of those other people. So I'm going to propose the update and send it to Bob, who is going to do the same thing. Bob has something called a responding flow that is triggered when I attempt to collect his signature on this particular transaction. So Bob's responding flow can run its own additional verifications, as well as the contract code that is shared between our two nodes. So once Bob says, yes, this transaction's good, the the flow framework will let node A know, hey, you don't need to do anything anymore. Or rather, hey, Bob has accepted your transaction. You don't need to do anything anymore. Now go give this transaction to the notary or the notary pool, as described here. And the notary pool can then sign the update. You can configure what the notary does with transactions. You can have very, very granular notary notary validation. For example, you can have the notary trace every single state and trace its entire history back to its original issuance transaction. Even if you're 10 years out, you can validate the entire history of a particular state object because it's all encoded onto the ledger, which is quite nice. Now we go back to node A, we record the update, A writes everything down, and then A goes back to B and says, hey, the update was validated, we're all good. And so B does the same thing. B writes it down in its copy of the ledger, and the transaction is complete. That is everything you need to know about flows as far as we're concerned in any event. So hopefully that makes sense to everyone. I just want to see if anyone has any questions before I go further here with bills of lading and letters of credit. Nathan Marshall asks, in this example about the car, there is no way to prevent the selling node from lying about the mileage, let's say, right? Yeah, so there's a couple of reasons you couldn't lie about the mileage. First off, great question. Thank you very much. The first reason you couldn't lie about the mileage is going to be because every other node that knows about this car's existence is going to have a different copy of what the actual mileage is. That's the first reason you wouldn't be able to lie. Because if A tried to tell B that the car had 30,000 miles when in fact it had 60,000 miles, there's two things. One, the car, when it was issued onto the blockchain, every single update to that car has to be approved by all the required signers. So if we had gotten to a point where the car had 60,000 miles and then one node tried to claim it did not, it simply would not pass through consensus. Meaning if the notary saw, I mean, it wouldn't even get to the notary, but I don't want to get too technical here, but essentially you would not be able to falsify the state because once you sent it to another node or more than one other node, those nodes would realize that this state is inconsistent with the remainder of the blockchain and your transaction would probably get rejected pretty quick. That's the short form of it. In the in the grand scheme of things, it's going to be very, very difficult unless you are able to break RSA 2048, and that's not going to happen anytime soon. All right, and the quantum computers are going to need another 20 years before they get anywhere close to that. So we're good, at least for now. Hopefully that answers the question, but if not, I'm sure Peter can get you covered there. But thank you for the question, Nathan. I appreciate it. All right, let's talk about bills of lading. So what is a bill of lading? If you were to actually go and Google search bill of lading right now, the definition isn't super clear, but we'll see if we can make things a little more intuitive. A bill of lading is a detailed list of the shipment of goods in the form of a receipt given by the carrier to the person consigning the goods. So what does this mean? Well, let's talk a little bit about the flow of what happens in international trade. International trade is an interesting example because both parties, the buyer and the seller, don't really trust each other. So what they do is they actually underwrite their risk with their banks. So what happens, in fact, is that the buyer would create a purchase order. I will tell you, I want to buy 1 million widgets or what have you. You come back. I come to you and I say, I want 1 million widgets. I then go to my bank and I say, hey, I want to buy 1 million widgets. I need a letter of credit from you guaranteeing to them that they will get paid even if I'm defaulting. So then my bank looks at my credit and says, okay, I am willing to underwrite the risk of this person paying party B, the seller, right? And if the bank approves and accepts the application, only then is the seller's bank notified, and then the seller is notified, at which point the seller can add a bill of lading and ship the product. They ship me my 1 million widgets. So far, so good. Assuming the seller has shipped me my 1 million widgets, then the seller's bank pays the seller, my bank pays the seller's bank on credit on my behalf. So no one is out of any money yet, but now I have credit that I owe to the bank, and the seller has been paid without us having to necessarily directly trust each other. So then, of course, I, the buyer, must then pay my bank. And that's the story. That's what happens. And the typical flow, obviously, this is very high level. There's a lot of nuance as far as what kind of, in a production use case, what kind of real work you'd want to put into your contract verification to make sure that you are actually including all of the parties that need to be aware of most of these transactions. But for this example, we're just going to have 4 parties that we're mainly going to be thinking about. So if this makes sense, feel free to post a question. I can take them. We can spend a minute here at least making sure we are all good. Let's see. I'll give it a second. Awesome. All right. I will take that as a positive that we are all good. So let's run with this a little bit more. Now, we've talked about the use case. We understand what the steps of this process are. So now I'm just going to go and model it for you. We will do that with a demo. So what we've done here is we've taken the older version of the letter of credit CorDapp, and I'm going to show you in the front end what this looks like. And then I'm going to show you the CorDapp itself, the actual Kotlin code that we've ported forward that's compatible with Corda 4.6. I'll also show you a couple of interesting tidbits to be aware of when using older CorDapps. There's some interesting things that you'll want to be aware of as far as outdated syntax and some consensus problems you might run into that are not super safe. So let's get started. Here, I'm going to open up my beautiful little menu, and we'll see that all of the things that I described have appeared here. Now I'm going to go and click right here, and now we can visualize more clearly who are the nodes that we're actually going to be working with. So here is the buyer, here is the buyer's bank, here is the seller, and here is the seller's bank. Straightforward enough. So the first thing I'm going to do is I'm just going to issue myself some cash. I'm going to be doing this using the Corda finance tooling. You can look into that a little more after the fact. So you'll notice my bank has $10 million in USD coin. Very cool. So I'll just transfer myself a bit of this cash to make sure that analog importers in London, specifically Liverpool, is able to purchase what we're interested in purchasing. So we're going to give analog importers 3 million in USD coin. So of course, analog importers is the importer, and Lookma exporters is the exporter. So great. Our bank seems to have $7 million in the bank, and our importers now have 3 mil. Awesome. So the first thing we're going to do is we're actually going to go and create a purchase order. Now, this is going to be a little bit painful to type all of this stuff in the forms. So I'm going to use a couple of shortcuts to make this a little bit less painful for us. First things first, we see that I've got my 3 million bucks, looks good. So I'm going to go and create a purchase order. So here are a lot of the details you'd expect. My purchase order contains things like a date, an ID, a term, the buyer's details, seller's details, the goods I'm actually purchasing. In this case, from my exporters, I'm going to buy let's say 100,000 OLED screens because I'm in the business of smartphone production. And so the seller in this case is Look Ma Exporters. So I create a purchase order. Amazing. And so there you can see my wonderful little purchase order document going over to the exporters. Now I've made this purchase order, but now I need to go and actually do something with this, right? I need to go and back this up. So I'm going to go apply for my letter of credit. And so every single one of these changes that we're making are actually transactions on the blockchain. And we'll start to see that in a little bit where you'll be able to visualize and see the transaction IDs to know that what you are looking at is actually legitimate. So I'm going to go to apply. I'm going to start my next transaction and you'll see that we have their transaction ID, etc., committed to the ledger. Oh, whoops, I did not select my issuing and advising banks. So my issuing bank in this case is going to be the First Bank of London. Nothing surprising there. The advisory bank is going to be the Shenzhen State Bank. So now that we've got those two in there, I'm going to go to apply and hopefully there we go. So I've just filled out my application, sent it over to the First Bank of London. Fantastic. So now let's assume that the Bank of London knows that I'm good for the money and that I can pay it out. So they are going to look at their letter of credit applications. They're going to see that they have one from Analog for 1,300,000 USD coin. I'm going to hit approve as the bank. And so you'll notice a couple things just happened. Now that I've approved the transaction, now that I've actually went and approved the letter of credit, now the shipping can happen, right? Now the other party can say, okay, I know that I'm going to get paid. So I'm going to put my stuff on the boat and I'm going to ship it out. Fantastic. So let's see how that plays out. The seller will add their bill of lading and ship. So that plays out pretty much exactly how you'd expect. So here we are. The Analog importers have an issued, note the status there, an issued letter of credit. And this can be verified just by going and looking at the transaction ID on the ledger. You can always do that at any step of this process. So first things first, I'm going to create a bill of lading. I'm going to outline that I am going to ship these items. Specifically, I'm sending them to, I'm sending them from the Maritime Center. I'm sending them from Shenzhen to Analog importers in Liverpool. So I'm going to hit submit. Fantastic. So I now inform both my bank, the seller's bank, and the buyer, both my bank, the buyer's bank, and and the buyer, sorry, that I've shipped the stuff. And so now you will see that it says laded as far as its status. And again, new transaction ID, totally visible to everyone involved. Now I can go and ship. So I'm going to confirm that I've shipped these LED screens. There's our little boat animation. Love it. Now the status has changed to shipped with all of the required signers being aware of that fact. Now that the items are in fact actually shipped, the buyer's bank can pay the seller's bank. Makes sense because the seller's bank will now pay me or pay the seller. Seller's bank also has 10 million bucks, but now they're going to pay me, or rather they're going to pay the seller. So I can go and look, now that I see that it's shipped, I can go and look at the specific bill of lading. I can see the hashes. I can go and make sure that everything looks good before going on to actually do my, before actually going and doing my transaction. You also can create nice little things like timelines to see how your states evolve with time. But for now, let's just leave the bill of lading and pay our seller. There you see that beautiful little pile of money moving from point A to point B. The seller has been paid. You'll notice that it says now the status is beneficiary paid. Quite nice. So now the buyer's bank can pay the seller's bank, right? Right now, the seller's bank is out 1,300,000 bucks, but I've paid nothing. And so my bank has guaranteed this. So my bank's going to pay them. Fantastic. Pay seller's bank. Our floating dollar signs make their way across the continent. There we are. This now will say advisory paid, right? Same thing as before. You can always view the bill of lading. You can always look at the transactions to determine what the most recent thing is that happened. Now that we've paid the seller's bank and the advisory has been paid, the issuing bank has to be paid. So let's go to buyer pays buyer's bank. You'll notice that analog importers is listed here, seller of look ma exporters. The advisory has been paid. I can go look at the bill of lading. Let's say I'm looking for the shipments or what have you, or I can just settle with my own bank. And there we go. We've now paid ourselves. We've done the entire life cycle of a international transaction that is trustless. It's pretty cool. Now, I've shown you a lot here, so I'm going to try to concretize, if that's the right term here, the abstractions I just gave you of states, contracts, and flows, and we're going to try to map them onto this. And I want to do that by jumping into the code. So before I jump into this and start looking at a bunch of these different things, let me go back here and say, does anyone have any questions about anything you've seen so far? All right, great. I'll take that. So one of the things I want to go back to actually in the slides is the right place to do this. We talked a little bit about states, contracts, flows. These each from a code quality perspective are defined in separate files. Every single one of these is separate. The states have contracts that are associated with them, but each state is separate. They're just classes in Kotlin or Java. The contracts are unique, generally speaking. The contracts tend to be specific to each state. So you would have, say, a car contract for every car. You would have an application contract for every application. And flows are all separate files because they're triggering different kinds of updates with different numbers of people that need to be involved. Me issuing a car onto the blockchain is very different than me issuing 10,000 new shares of stock. Those flows are going to look very different. And that's the point I want to bring home here. So let's go look at the code and we'll notice a couple interesting things right off the bat. So we're going to look specifically, for the sake of time, at the workflows, which will contain all of our flows, and also the states and the contracts inside of the contracts module of this CorDapp. Any of you who've done CorDapp development recently will hopefully find this familiar. This will not be news to you. So let's start by looking at the first file that's going to be useful for us, the purchase order state, right? Now, this is the thing we started with. I'm buying something from you. So how does that go? I have to define a class that specifically outlines what is a purchase order state, who is the owner, the seller. These are just instance variables. You can call them whatever you want. I'm using that Corda abstraction of party for the data type, but the idea is the same. So in this case, a purchase order is going to have an owner and a seller. It's going to be consumable. It's going to have properties. It's going to have a list of participants as well. These are participants that must be informed of transactions that apply to this particular state. And so their their signatures tend to be needed. One last thing I want to point out here is the linear state. So a linear state is a Corda abstraction that we are implementing here. So our purchase order state is going to have something called a linear ID. This linear ID is unique to a particular state. So when our state changes with time, we can look up the linear ID, make changes to the state, improve it with time, and adjust it with time. This enables us to do a lot of very cool things. So we can take our linear ID and use it to make updates on the ledger, to customize the objects that we're dealing with, et cetera, et cetera. So when we generally run flows, we're going to look up objects by this linear ID without beating the point too far. And one last thing I did not mention, the properties, is this purchase order properties data class that just contains some additional information. This is nice because it's just a little more convenient for us when we're working on some other tools. Now it looks like Zeki Alem, if I've got the name correctly. I understand this is a simple representation. How are validations happening and getting integrated? Example, do I know how the item was shipped and is on the loading dock? So your question could be answered two different ways. The first one is what I'm about to get to with contracts. So I'll set that aside for a second and start and do the second one. How do I know the item was shipped and is on the loading dock? So this depends a little bit on how you implement your CorDapp. So there's two things you could be talking about. The first is the idea of something called an oracle. An oracle is a common concept in blockchain where we wonder, how do I introduce data that is not on the ledger onto the ledger or into the digital space? So a great example of this is something like stock trading. So if I am a brokerage and I want to introduce data off ledger, such as the stock price, how does that get introduced into a Corda flow? There's a couple of different ways to do it. I would point you to the Oracle documentation, but the short answer is it's a solved problem, but it depends on how solvable. So an Oracle can be a little bit tricky because if you have something like, what is the price of X, Y, or Z object at this, or this brokerage? That's kind of a hard question to answer. There are some interesting tools to solve this, like Guy. If you're familiar with the MakerDAO ecosystem, they use something called a decentralized Oracle in order to remain decentralized as a currency. It's a bit different for us because we're using a permissioned blockchain where we know who people are. We don't need that anonymity. It's not as useful for us. So oracles can be a pretty interesting deep dive for you for your second question. And the other point I wanted to make about it is that to a certain extent, the problem with oracles is that whatever oracle you use is an oracle. You are trusting the oracle to give you the source of truth or the state of the world. And you don't always know what that is. And you don't always know how much you can trust the person who's giving it to you. So for example, decentralized betting markets are really fascinating. So you can go onto Augur, if you've heard of that, and they will have betting markets. Yes, you can have RFID data in an oracle as well, if you wanted to. It would, if I'm understanding RFID correctly, but really you can have anything. You could have anything that was possible to get from the outside world if you trust the oracle that's going to give it to you. So for example, let's say all of you are using the same maritime transport company. You could treat their API as an oracle, assuming that you all agree that they're probably going to be honest and tell the truth because they don't have an incentive to lie, let's say. Then you could all agree that maybe the maritime transport company's API is a reliable oracle, as long as it is deterministic when you run your contract verification. And so I should probably get to that without talking for too long here and belaboring the point. So let's look again. Now we're looking at the contract state. By the way, let me know if this code is not clear, it's not visible. So we have a bunch of imports. That's the usual. One thing I want to point out. Oh, whoops. Sorry, I'm in the wrong file. What am I doing? RFID picks up the item that was on the loading dock. We're good. I see. Cool. So let's look back at this state for a minute. There was one detail that I didn't really point out. That was this decorator belongs to contract. This specifically and uniquely identifies the contract that this state corresponds to. And so we can go look at the purchase order contract that corresponds to the purchase order state. Those names are conventions, by the way. You could name your contract and states whatever you want, as long as you explicitly link them with the decorator. Corda doesn't care. It's just a convention. And it's one you'll want to keep because it helps keep things clear as far as what you're working on. So here we are. We were just looking at purchase order state, and now we're at purchase order contract, the contract that explicitly is tied to the state. And now let's talk a little bit about some of the abstractions we talked about earlier. I mentioned in the car example, a car is an object that can be manufactured, it can be sold. Those are commands. I can issue a purchase order contract, or sorry, I can issue a purchase order state. I can lock the purchase order. If I give you a contract and you sign it, we consider that locked. It is binding. Assuming we've each presented, I believe the standard, we've each presented an objectively reasonable outward manifestation of our intent to contract, and we will sign our contract. That contract is considered legally binding, and performance is now due on that contract. So we can lock our purchase order. But once performance has occurred, we can nullify the contract or extinguish the contract. That is entirely possible for us. And so these are commands that we can apply to our state. And so this is where our verify method comes in. We essentially have a for each loop or a switch statement that happens inside of here, just to make things clear for the sake of this. There's some nice things you can do with decorators and If you're really curious, I'd recommend looking into the contract SDK if you are thinking about using something like something a little more robust or more elegant for writing your code. So here we have a when statement on command.value, and we essentially say for commands.issue, if we are issuing a purchase order contract, this is the code that's going to define what the verification will be when we issue a purchase order contract. And so here is where the real power of this framework will come into play, because now we can do a couple of intuitive things. The first is kind of obvious, right? If I'm issuing a purchase order at the meta level, at the metaphysical level, we need to know that there's only going to be one output. If I'm creating a letter of purchase or a purchase order contract, that purchase order there can't be more than one. I'm only going to introduce one specific purchase order. It does not get duplicated. Separate purchase orders are separate. They have their own unique linear IDs, as we talked about. So when I create my purchase, if I'm issuing a new one, there can only be one. Failed requirement during issuance of the purchase order. Only one output purchase order state should be included in the transaction. So if the transaction's output's size is not equal to 1, we just raise an exception. That's all we have to do. And we have a series of other requirements that we can apply. We can require that there's no input state. This makes sense because it's an issuance transaction. There was no previously existing contract that we're amending. The transaction is signed by the purchase order owner using commands.signers.contains, etc. This makes sense. If I'm going to create a purchase order, I have to know about it. I have to sign it. That's the only way. The seller and the buyer, that's a typo, must be different. In this case, we check issue output.props.buyer.name does not equal issue output.props.seller.name, right? The buyer and seller have to be different. I don't buy things from myself. That might look like money laundering, some kind of thing like that. And we don't want that. Similar thing with the purchase ID. We need to make sure that the purchase order ID exists. And the number of actual items, the term of the contract should be non-zero and positive, and the date for the actual payment to happen, that should also be specified. There must also be goods associated with the purchase order. So if this is making sense, then things like locking the purchase order should also make sense. In this case, we make sure that the input purchase order is marked as consumable if we're going to lock a contract. So we make sure that's the case. Then we're also going to make sure that it's not marked as non-consumable, or rather the purchase order in the output should be marked as non-consumable. So we can validate that as well. And there's lots of other validations we can add. And when we get to the point of production CorDapps, we have much more robust CorDapps that we're applying to this kind of a thing. So that's good to be aware of. But if this is starting to make sense to you, then the next piece of the puzzle, our flows, are going to feel really powerful. And by the way, even though I'm skipping over some of these other contracts for convenience to save a little bit of time, all of the things I'm showing you are similar. The contract verification here is just not as fleshed out. That's left as an exercise for the viewer, if you are so inclined to try it. Now, creating a purchase order flow is the last piece of the puzzle. We said that flows were the initiation of a transaction between A and B, right? Now, in this case, I'm creating a purchase order flow. So what do I need to do that? In this case, let's look back at the constructor and see. So this is where all of these ideas synthesize and come together. If I'm going to take my Corda node and tell my Corda node to tell your Corda node that I want to buy something from you, I have to specify, who are you? What am I purchasing? When will these things be done, right? That's where I supply these things to the flow framework, and the flow framework runs my Corda flow and does all the hard work of communicating with you, building the transaction, and passing it on to the notary. So we'll take a look at that in a second. I'm just going to get a sip of water. Excuse me, just a lot of talking. Okay. So look on line 20. The first thing that we see in this flow, funny enough, is actually just a logging thing. You don't need to specify the progress tracker, but it is very convenient. When you run your flows in the Corda shell, which is another thing that you should take a look at after this, when you run your flows in the Corda shell, the states actually get identified here. There's a really nice little pretty print mechanism as well. It's nice if you can try configuring something like this. It can save you a little bit of headache when debugging as well, because the first thing we do, our flow starts executing in the call method. The call method returns a signed transaction. So you'll see that here. The first thing we do is we set the current step. Where are we in the flow? That is on line 25, where we get the notary. On 26, we ask the service hub, which is a Corda abstraction. We ask the service hub to give us a reference to all the notary identities. In this case, because it's just an example, we just take the first one. All this is this is the notary we're going to use to validate our transaction. Now, if that works, then we'll go on to get an identity of the seller. Now, in this case, we ask the service hub to get a party from the name. In this case, we pass the seller name to the flow because the seller name is just a string, right? So if I typed in for my flow, if I type in the name Bob to initiate a transaction, Corda has the ability to look up Bob's Corda node, right? With just the name, intuitive enough. Now that we've found Bob's node, and if we don't find the node, we throw an exception, that's line 30. We go on to create a purchase order state, and that's just creating a state object. We're just initializing, we're just using the constructor of the purchase order state and creating a purchase order. Simple enough. So that's line 31. On the next line, we define the command. In this case, we're creating a new one. So we're going to use an issue command. And the second argument to the command constructor is, who are we, right? I'm the person initiating this, so I'm passing a list, in this case, a singleton list of my own owning key. This is just a public key, which is, we define a Corda public key abstraction. That is not an Apache thing. So just be aware of that fact. So underneath that, what do we do next? We create a builder. This is the transaction builder abstraction, again, from Corda. We pass the transaction builder a reference to the notary that we got earlier. Then we add the output state. That is the purchase order object that we constructed just a couple lines ago, right up there on 31. Now that we've got the purchase order and we specify the purchase order contract's ID, now we're ready to really go somewhere with this. So the next thing we do is we add a command. That command for this transaction, if this picture is starting to come together, every transaction is going to have an output state and a command and usually input states. And that's what we've done here. We take the issue command we just created and specify that as an input for the transaction builder. And now that we've built the transaction, all that we have to do is just go and call builder.verify to verify the transaction is legitimate. Then we're going to sign the transaction ourselves. We ask the Corda service hub to locally sign the transaction, mark it as valid. Once that is done, then we will initiate a flow to the seller. The seller is the required signer in this case. That is the person that needs to know that we are purchasing something from them. And once we do that, we start finalizing the transaction by calling initiate flow to the seller, and then we pass these sessions to something called Finality Flow. And I didn't explain exactly what these are, and we don't need to worry about it too much for the purposes of this conversation. But initiate flow is something called it's one of the subroutines Corda gives you to initiate the flow and create a session, a communication session, we'll call it, between you and the seller, between your Corda nodes, rather. Once you have those sessions, you can pass those sessions to another tool, a subflow, just a subroutine you can call provided to you by Corda called Finality Flow. And what Finality Flow will do for you is everything that we outlined in this diagram. Finality Flow will take this part of the process, because this is where we are. We've just signed our transaction ourselves. We're now ready to go and publish it out to all of the required signers. Finality Flow takes over from here all the way to the end of the process. Assuming we've defined our notary in the transaction builder, which we did, now we can take from node A and beyond as the Finality Flow's responsibility. So that means IO, latency, network hang, disk failures. I mean, well, maybe not disk failures. Assuming you have redundancy on the other side with your Corda node, then disk failures. Any blocking IO, anything that gets in the way, if the flow hangs, Corda's flow framework will handle all of that for you. All you have to do is just specify that this is the subflow that will collect the signatures from all of the other nodes and inform all of the other nodes to validate this particular transaction. Once those things are done, you are good and your transaction is considered complete. You're probably wondering, I've left a particular piece of code commented out here. This is a fun fact from Corda 3, and I'm curious to see what you guys think. You'll notice here that Finality Flow is being called without target sessions. So why do you think that might be? I'll leave it for a couple seconds and see. Maybe you can, why would it be a bad idea to then run Finality Flow without passing the sessions? Because in Corda 3 and in Corda 3 and earlier, you actually could do this. This method call is now deprecated. If you have an idea, you won't have to hold it for too long because I'm going to give away the answer here. Finality Flow, if you look inside the documentation, we do have a little bit of nice IDE notes that you can use. So Finality Flow is unsafe because it requires nodes to automatically accept notarized transactions without first checking their relevancy. Instead, you should use one of the functions that require flow sessions. So there's a fun fact for you. It's dangerous to, and this makes sense, it's dangerous to start signing your transactions before you've made sure that other people around you are aware of them and willing to do things with them. Let me comment that back out just for the sake of thoroughness. Nathan asks, so what if you modify the finality flow so that it would next execute the last message to the seller? Then you, the buyer, would not have an updated state, but this would have an updated state, but the seller would not. Why wouldn't the notary update all pop? Oh, I see, would not execute. What if you modified so that it would not execute the last message to the seller? Nathan, are you asking like if you wanted to trick another party, modify the finality flow? Is that what you mean? I see. I think if you did that, you'd probably still get hung up on the notary because they need to have consensus on that last state. You can customize how thorough and how rigorous you want the notary to be. If you want the notary to really be like ironclad, those validations can take a little bit longer. So be aware of that. But I'm wondering, could you mess with the flows to make something sneaky happen? You, the buyer, would have an updated state, the seller would not. The notary update on part. I mean, I think the notary just would. Now, this is a little bit towards the, if I'm being honest, this is a little bit towards the boundaries of my knowledge of how the notary deals with the, oh, I see. The diagram showed the notary only sending its signature to one node. I think the diagram in this case is optimized for simplicity, but you are at the border of my knowledge of the nuance of how the notary manages this. To that, I would refer you to the documentation on notaries. Our CTO breaks down specifically how consensus happens at a more detailed level. So I'm sorry, I don't have a great answer for you here as far as the right way to do it. If you wanted to try to trick someone, and the best answer, I don't have the best answer for you, but I believe that this diagram is just a simplified version of the state of the world. Meaning, I think what actually happens is the notary goes back to all of the required signers and tells them all separately. I think that is what happens. But your point is well taken because the notary does have a lot of responsibility and the notary is hosted. So you can do some interesting things here. Like, for example, if you have a pool of notaries, you'll notice here that we called it the notary pool, not the single notary. This is because in your CorDapp, when you compile your CorDapp and distribute it, it's a CorDapp you compiled ahead of time. The reason that's interesting is because you could, for example, randomly select your notary every time. So if you had, let's say, 100 notaries, you wouldn't, but let's say you had 10. You could have each out of the notaries, you could have them hosted by different parties, and then you could randomly select them so that because you don't know whose notary is going to be selected, you get kind of a pseudo proof of stake situation where because we don't know whose notary is going to be selected, no one's got an incentive to start messing with their notary to trick everyone else. That's kind of a fun way to think about it. But as far as the specifics of how the notaries really do coalesce and prevent tricks, I would say this diagram is definitely a simplified view of the world. So yeah, I hope that answers the question. And with all that being said, I definitely want to be respectful of everyone's time. So I'm going to run over there we go. So we've already looked at our code. Just for any of you who are curious, we're going to be sending out an email after the fact with a survey that I would ask you to fill out. And it will also contain the slides, I believe. And so you can find all of these CorDapps. I've backed them up, the original ones, as well as the front end that we looked at earlier, and the source code of my revamped form of the CorDapp. That is all going to be on GitHub. You can find that shortly after this. So I highly recommend you do so. And with that, I want to thank everyone for watching. You can find us on LinkedIn at R3CEV-LLC. You can find us on Twitter and also on Slack. I am at David Awad and Peter is at Peter Lee. You can also find our new developer training on training.corda.net. And with that, I will cut off the recording, but I will take some questions if anyone is interested.